So for the next section, 23 and on, it says find the roots for each of the following. Well, find the roots is really just another way of saying find the solution, so solve the problems. So we're going to try to find the best method to do all of these. So for the first one, 23, I've got x squared minus 10x plus 24 equals 0. I'm going to start by seeing if I can factor. So here we'd get c on top, which is 24, b on the bottom, which is negative 10, and I'm going to look for two numbers that multiply to positive 24 and add to negative 10. And those two numbers would be a negative 6 and a negative 4. Alright, so now I'm going to put those into my factors. X minus 6 times x minus 4 equals 0. And now I set each one equal to 0. So we get x minus 6 equals 0 and x minus 4 equals 0. And so for x minus 6, I'm going to add 6 to both sides, and I get x equals 6. And for x minus 4, I'll add 4 to both sides and get x equals 4. And there's our two solutions for this one. Now moving on to number 24. Notice 24 has a parentheses squared. There's only one x. It's inside of the parentheses. It's being squared. So the best method for this one is to use the square root method. So if I use the square root method, remember our beginning goal is to get what's being squared by itself. So I want to get x plus 9 squared by itself. It has a negative 3 in front. So to get rid of that negative 3, I'm going to divide by negative 3, and I have to do it to both sides. And so those would cancel. We get x plus 9 squared equals positive 21. And now that we have what's being squared by itself, we're going to use the square root to cancel out that squared. So if you remember, the squared, the second power, and the square root are inverse operations. Just like above how we use division to cancel multiplication, these two cancel out. So on the left side, we're left with x plus 9 equals, and on the right side, when we take the square root of a number, we always get plus or minus the square root. Now, once I get rid of the squared, I want to try to get x by itself. So again, we're trying to get x alone. I need to solve for x by getting rid of that 9. So it's plus 9. I'm going to subtract 9 from both sides. Get x equals, now the radical and the number are not like terms, right? We can't combine them. We just get negative 9 plus or minus the square root of 21. Now, once you're here, before we box our answer, we want to see if we can simplify anything. So, is the square root of 21 a radical that we can simplify? Is 21 a perfect square? No. Is 21 divisible by a perfect square? No. And so this is a final answer. All right, let's try 25. Again, notice in 25, I only have one x, and it's being squared. So I'm going to, again, use the square root method. I need to start by getting x squared by itself. Notice there's a negative 3 in front of it and a minus 9 behind it. When we try to isolate, we do PEMDAS backwards, order of operations backwards. So the first thing I'm going to do is any addition or subtraction. So I notice that it's minus 9. So I'm going to cancel that first by adding 9 to both sides. And I get negative 3x squared equals 9 plus 3 is 12. Now I'm going to try to get rid of the negative 3. And it's negative 3 times x squared, so I will divide by negative 3 on both sides. And I get x squared equals 12 divided by negative 3 is negative 4. And the next thing we want to do is take the square root of both sides to cancel out that squared. And I get x equals plus or minus the square root of negative 4. And now I need to see if I can simplify the square root of negative 4. So, is 4 a perfect square? Yes. The square root of 4 is 2. But notice it also has that negative in front of the 4. So that, if you remember, the square root of a negative we weren't able to do before. But now we can do it because we learned about imaginary numbers. So when you take the square root of negative 4, you should get 2i. So the square root of 4 is 2. The square root of a negative is I. So our final answer, still with the plus or minus, is x equals plus or minus 2i. All right, for 26, notice again, we have two different x squareds, but we only have x squared, right? There is no x term. So I could combine those two together and be down to just having one x and still use the square root method. So that's what I'm going to do. I'm going to get the x squareds together. So I'm going to add x squared to both sides because I don't like negatives. And I get 4 equals 3x squared minus 5. And so see here, I've only got that one x squared term. And so I'm going to solve using square roots. So when I do that, again, we're going to get x squared by itself by using order of operations in reverse. I'll start by adding 5 to each side. 4 plus 5 is 9, and that equals 3x squared. Now I need to get x squared by itself. I'm going to divide both sides by 3. I'm going to get 3 equals x squared. And now to get rid of the squared, we would want to square root both sides. Remember, when we take the square root of a number, we get plus or minus, and that equals x. Can we simplify the square root of 3? Well, it's not a perfect square, and it's not divisible by any perfect squares, and it's not negative, so there's nothing we can do to simplify it. This is a good answer. If you prefer to write it in this order, you can always switch it. That's not going to affect anything, but you could leave it in that order as well. And so our final answer is x equals plus or minus the square root of 3. All right, for 27, I have x squared plus 5x plus 1 equals 0. Now, when you see three terms like this, you can definitely try to do big X. So if I try big X, C is on the top, B is on the bottom. Two numbers that multiply to 1 and add to 5. Well, I don't know of any. So that tells me factoring is not going to work. Instead, I need to use the quadratic formula. So for quadratic formula, you need to make sure, 1, that you are set equal to 0, and then 2, that your equation is in standard form. So x squared, then x, then the constant. And this one is. So we're ready to get started. First thing I want to do is find a, b, and c. So a comes from the x squared. If there's no number in front of it, then we know it's an understood 1. The b comes from the x term, and I see there's a 5 in front of x. And then c is the constant. It's plus 1. That 1 is the constant. Now to plug it into the quadratic formula, I'm going to start by writing the bare bones version. So it's negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And what I'm going to do is just plug in a, b, and c wherever they go. So it was a negative b, so I can plug in 5 here, a b squared, 4 times a times c, and then 2 times a. So we just plug in our numbers like that, and then we simplify. So in the front, I have a negative 5 plus or minus square root of 5 squared would give me 25, minus 4 times 1 is 4. So 25 minus 4 is 21. Remember, for this step, you can use your calculator, but only plug in what's under the radical in your calculator. So in my calculator, I would plug in 5 squared minus 4 times 1 without the square root. and then I would see that it's equal to 21, and I would put it under the square root. And that's because if you were to get a number that's not a perfect square, if you plugged it into your calculator already in the square root, it's going to give you a decimal. And we're not going to leave decimals in our answers. All right, so now this is over 2 times 1 is 2. All right, so the next thing I want to check is, can I simplify that radical? Can I simplify the square root of 21? Well, is it a perfect square? No. Is it divisible by a perfect square? Again, this one's not, so I can't simplify that radical. The second thing I want to check before I'm totally done is, can I simplify the fraction? We look at the number in front of the radical, and the denominator. And we're looking for a greatest common factor of all three of those numbers. So here we have -5, 1, and 2. Is there a GCF between those three? There's not. So there's nothing that we can simplify here. This is our final answer. All right, now for 28, I've got 4x squared minus 8x equals -1. I'm going to start by getting it equal to 0 because I know I'm not going to use the square root method since there's both an x squared and an x term. So I'm between factoring and the quadratic formula. So my first step is going to be to get it equal to 0. I get 4x squared minus 8x plus 1 by adding 1 to both sides equal to 0. And I can try to do big X, and if I try big X, notice that A is not 1, so I have to do 1 times 4 up top, so 4, and then -8 on the bottom. Are there two numbers that multiply to 4 and add to -8? Nope, so that's not going to work. Instead, we've got to use the quadratic formula. So we're in standard form, we're equal to 0, and we're ready to find A, B, and C. So A is 4. B is -8, and C is 1. Now I can plug in, I'm going to write out bare bones, so we've got -b plus or minus square root of b squared minus 4ac all over 2 times a. And I'm going to plug in the number. So b is -8. A is 4, C is 1, again A is 4, and now we're ready to simplify. So in the front I've got a -8, and a double negative becomes positive. Under the radical we've got 64 when we do -8 squared, and make sure that when you plug it into your calculator you use the parentheses. Otherwise your calculator is going to try to tell you that it's a -64 when really it's a positive. Minus 4 times 4 times 1 is 16. And so then we're going to do 64 minus 16. And that's 48. So that's what goes under the radical. Again, you can use your calculator. Over 2 times 4 is 8. Next thing I want to do is see if I can simplify the radical. So, is 48 a perfect square? No. Is 48 divisible by a perfect square? Yes. 48 is divisible by 16. So if you don't remember simplifying radicals, over here we got the square root of 48. I can break it up into its factors, 16 and 3. They're still under the square root because 48 is under the square root. And now I just take the square root of each. So the square root of 16 is 4, and the square root of 3 is a decimal, so we leave it as square root of 3. So I can substitute that in for the square root of 48. So this becomes 8 plus or minus 4 radical 3 over 8. We've simplified the radical. Now the last thing to do is see if I can simplify the fraction. So remember, we look in 3 places: the number out front, the number in front of the radical, and the denominator. Is there a GCF between all 3? Yeah. 8, 4, and 8 are all divisible by 4. So I'm going to simplify them by dividing by 4. I get 2, 1, and 2. So when I simplify this, we get 2 plus or minus the square root of 3 over 2. And there's our solution. So that's what x equals. There you go. I think that I did not write x equals on this last one, so let me fix that real quick. Remember, all of these solutions are your x's, right? We're solving for x, so it's best to write x equals our solutions. All right, let's move on to number 29. So I've got 4x squared plus 5 equals negative 7. For this problem, I only see one x, so I'm going to use the square root method. I'm going to start by getting x squared by itself. So the first thing I want to do is subtract 5 because we do PEMDAS backwards. I get 4x squared equals negative 12. Next, I'm going to divide by 4, again trying to get x squared by itself. So we get x squared equals negative 3. And now I'm going to square root both sides to try to get rid of that squared on x. So we get x equals plus or minus radical negative 3. Now when I have the square root of negative 3, I want to try to simplify. 3 is not a perfect square. It's not divisible by a perfect square, but notice there's a negative under the radical. We can never leave a negative under the radical. We have to always pull it out. If you remember, the square root of a negative is I. So all we do is pull out the negative. It becomes an I, and then it's gone from under the radical. So the final answer for this is x equals plus or minus I square root 3. All right, number 30. I have both x squared and x terms, so I'm going to now get it equal to 0 to start. So I'm going to move the 3x squared over because it's negative right now, and I know I like x squared to be positive, so I'm going to add 3x squared to both sides. I get 3x squared minus 4x plus 2 equals negative 2. Now I want to move that negative 2 over, so I'm going to add 2 to both sides. 3x squared minus 4x plus 4 equals 0. All right, so we've got our equation. I'm going to attempt to do big X and see if it works. Notice there's an a that's not 1, so I need to on top do a times c. So 4 times 3 is 12, and then b, negative 4, goes on the bottom. Are there two numbers that multiply to a positive 12 but add to a negative 4? No, there's not. I can't multiply to a positive 12 and add to a negative 4. So I'm going to have to use the quadratic formula. It's in standard form, so I'm good to just label a, b, and c. So a is 3, b is negative 4, and c is 4. And now I'm going to write out the bare bones. So we've got negative b plus or minus square root of b squared minus 4ac all over 2a. And now I'm going to plug in a, b, and c. So we've got b first, and then another b, a, c, a. And now we want to simplify it. So out front, a negative 4 is positive 4. Under the radical, negative 4 squared is 16, minus 4 times 3 times 4 is 48. So we get 16 minus 48, which is a negative 32, over 2 times 3 is 6. Okay, so now we've got our possible answer. The first thing we want to check is, can we simplify the radical? So, is 32 a perfect square? No. But is 32 divisible by a perfect square? The answer is yes. So 32 is divisible by 16. I'm going to break it up into its factors. This time I get one extra factor though, because notice it's a negative 32. So when I take the square root of negative 1, I get I. The square root of 16 is 4. And the square root of 2 remains square root of 2. So I'm going to put this together. We get 4I square root 2. And I'm going to put that back into our answer. So now we have 4 plus or minus 4I square root 2 over 6. The next thing I want to do is see if I can simplify the fraction. So I look in 3 places: the front, in front of the radical, and in the denominator. We've got 4, 4, and 6. Do those 3 numbers have a common factor? The answer is yes. They're all divisible by 2. So I'm going to simplify them by dividing by 2 to all 3. So 4 divided by 2 is 2. 4 divided by 2 is 2. And 6 divided by 2 is 3. So this reduces to 2 plus or minus 2I square root 2 over 3. Notice I did not touch the 2 that's under the radical. That is off limits. You can't touch this. You can only simplify these 3 numbers. Now I'm going to make sure to write x equals this time, and there's our final answer. All right, looking at 31, I've got both an x squared and an x term, so I'm going to start by getting the equation equal to 0. I, of course, like to keep the x squared positive, so I'm going to move the 3x and 1 over. So I'll subtract 3x from both sides. 5x squared minus 3x equals negative 1. And then I'll add 1 over. I get 5x squared minus 3x plus 1 equals 0. All right, now I'm going to try to factor. If I set up big X, we would do 1 times 5 on top, and then b negative 3 on the bottom. Are there 2 numbers that multiply to 5 and add to negative 3? Nope, there aren't. So that's not going to work. We have to use the quadratic formula. It's already in standard form, so I can say a is 5, b is negative 3, and c is 1. And I'm going to write out the bare bones. So we get negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so now I'm going to plug in a, b, and c where they go. So it's b, a, c, a. And now I want to try to simplify. So starting with the front, negative 3, I'd get a positive 3 plus or minus the square root of negative 3 squared is 9. Minus 4 times 5 times 1 is 20. And 9 minus 20 is a negative 11 over, and then 2 times 5 is 10. Now, with negative 11, the next thing we want to do is try to simplify the radical. Is 11 a perfect square? No. Is 11 divisible by a perfect square? No. Is 11 negative? Yes. Since it's negative, even though I can't simplify the number itself, I need to pull out I. So, this becomes 3 plus or minus I radical, now positive 11 over 10. Next, we want to see, can we simplify the fraction? So we check the number in front, the number in front of the radical, and the denominator. 3, 1, and 10. Do they have a common factor? And the answer is no. So this is our final solution right here. All right, now the last one for the section is number 32. I've got 9x squared minus 30x plus 25 equals 0. So with this problem, I could try to factor and do big X. I'll write it out. Notice it's already equal to 0 and in standard form. When I do this, I have to do 25 times 9 up top, which is 225. And then it would be negative 30 on the bottom. Now, these are some big numbers, so if you don't want to spend a lot of time thinking about it, you could always just use the quadratic formula. But this one actually does factor. So two numbers that would multiply to 225 and add to negative 30 would be negative 15 and negative 15. 15 times 15 is 225. So negative times negative is positive. And then negative 15 plus negative 15 is negative 30. All right. Now remember that extra step because we multiplied by a on top. We divide by a on the sides. And I want to reduce it if I can. So negative 15 over 9, while it doesn't divide evenly, will reduce to negative 5 over 3. And the same on this side. So in our factors, we get x minus 5/3 times x minus 5/3 equals 0. We don't ever leave those denominators, so they go up to be the coefficients of x. I get 3. Ooh, I don't like that. I get 3x minus 5 times 3x minus 5 equals 0. Now I'm going to set my factors equal to 0. Now if you notice, our two factors are the same. So it's not absolutely necessary to actually solve both of them because they're going to get us the same solution. But if it makes you feel better, you can write it all out. So when I add 5 over, I get 3x equals 5, then divide by 3, x equals 5/3, and over here, again, it's the same exact process. It's going to get you the same answer, but it doesn't hurt to write it out. I get x equals 5/3. Now, just because I get it twice doesn't mean it's two separate solutions. It's only one solution. We'll learn about what this means later in the semester. But we have one solution, and that is x equals 5/3.